So hello students, welcome to the science learning. Okay, in this video we will discuss about the basic concepts of chemistry and like symbols of elements, atomic number and the electronic configuration of elements, and also how to find the valency of elements. We will also look some examples of chemical compound formulas which will help you in further studies. Okay, now the concepts today's which we will be learning today will help you in further studies. So far you should learn those things and have good concepts about the materials and concepts. So let's start. Yes. Now first we will discuss about the first 20 elements of symbol, atomic number, the electronic configuration and the valency chart here. Yeah. Now first two tables. Okay, let's see this. Okay. Uh, Very differently. Okay, I have made this chart as how you can remember by the phase. Okay, now for hydrogen high. Okay, now for helium. Okay, it's hello. Then for lithium, it's listen. For like this, for remembering purpose. Okay, I made this table. This is the extra table. Okay, this you can ignore it, or for the nitrogen use oxygen O. Okay, for better understanding I have made this column here. Yeah. So let's look, okay, these two tables, which is the elements and the symbol column here. Okay. Now first 20 from hydrogen till the calcium. Okay. Now for hydrogen, okay, we represent the hydrogen. Okay. Its symbol is H. Then for helium element, it is He. Now for lithium element, it is Li. Then for beryllium element, it is Be. For boron element, how do we symbolize or how do we represent? It is B. Then for carbon, we have C. Then for nitrogen, we have N. Likewise, for the oxygen, O, fluorine, F, neon, Ne, sodium, Na, magnesium, Mg, aluminium, Al, silicon, Si, phosphorus, P, sulfur, yes, chlorine, Cl, argon, Ar, potassium, K, calcium, Ca. Now these were the first 20 elements from calcium to the hydrogen. You have to remember these two like column elements and the symbol, because without knowing of these elements you can't write the formulas or the reactions. You should remember different elements with its atomic number and the symbol. Okay, we have this column also, atomic number, electronic configuration, and also one table we have valency, that we will be looking in the further. Okay, so this only you can like able to okay create the formulas or the reactions. Okay, these are the things. Now let's look into the electronic configuration part. Okay, so before starting with the electronic configuration part, okay, let me tell you what is atomic number here. So I think you can just see here. Okay, now what is this atomic number part? Okay. Yeah, atomic number, that is nothing but it is equal to the number of electrons or the number of protons in an atom. For example, let us take the hydrogen. Now hydrogen, it has atomic number of 1 then. Okay, it has the atomic number, okay, of 1. Then how many electrons are present in it? It is 1 only. Similarly, the other elements. Helium has how many atomic numbers? It is 2. That means it consists of 2 electrons. Similarly, we have this lithium of 3 atomic number. Beryllium has 4. Boron has 5. Okay. Carbon has 6. Like this, we have this atomic number. Likewise, we have this atomic masses also, which is equal to the number of neutrons. Okay, which is equal to the number of neutrons here in an atom. Okay, now let's look into the upcoming diagram, the structure. Okay, now what do you see? Okay, this is a structure of an atom here. Now this is a structure of an atom. In the center we have this nucleus. Okay, now this is nothing but the nucleus part. Okay, now this is nucleus part. So in this nucleus, what do we have? It is nothing but, okay, here we have the protons and neutrons. Okay, now protons has positively charged and the neutrons has no charge as it is neutral. So charge of nucleus is positive, okay, because of charge of protons. Okay, now what do you see the outside of nucleus there? Okay, this outside of nucleus, okay, it has the orbits and the shells. These are the path for the electrons. Okay, now these are the path of the electrons, in which the electrons will revolve around the nucleus in an atom, okay, in this shells or the orbits there. Now, what we can see in this first shell, it is the K shell. It is known as K shell. Likewise, we have the second shell, that is L shell. Then we have third shell, which is M shell. Then we have N shell, which is the fourth shell. Now, in the first shell, okay, in the first shell, it is only having two electrons. Only two electrons can fit in an first shell. Similarly, we have in second shell, that is L shell, only 8 electrons can present. Then in M shell, how many electrons can be present? Or it can, the limitations of the electrons can be present in M shell, it is 18. Okay, now, and for N shell, it is 32. Okay. So these are the distribution of shells in an atom. Okay, for writing the electronic configuration, okay, what we have to do? We have to make like this. We have to make like this. K, L, M, N. Okay. Suppose let us take an element of carbon. Okay, let us take an element of carbon. Then element of carbon consists of how many electrons? It is 6. Okay. So how many electrons are present in the carbon? It is 6. So 6 electrons. So we have to distribute the 6 electrons in this all 4 shells. So how we can do it? Let us see that. So K shell, how many electron, maximum electrons it can be fit up to 2 electrons. So 2 I will do this here. Now what is 6 minus 2? 6 minus 2 is 4. Okay, now this 4 I will put into L shell. Okay, and the limitations of the L shell is up to how many maximum electrons it can fill? It is up to 8 electrons. So from 6 electrons, 2 electrons have been filled in the K shell. Okay, and the remaining, how many electrons are remaining in? That is 6 minus 2, 4. So 4 electrons are present in the L shell. So like this, we can write the electronic configuration of an carbon. So 2, 4 is an electronic configuration of a carbon. So you can see, okay, and the sixth, okay. So you can see the carbon's electronic configuration is 2, 4. So let us take an example of magnesium there. Okay, now magnesium will, let us see how we can write that. So first, what is the step to write an electronic configuration? The easiest way of the writing of an electronic configuration here of an any element. First, write how many electrons are present. That's why the knowledge of having how many electrons are present in an element is very much important. So we'll have how many magnesium electrons are present. It is 12. Then next step is K, L, M, N. Okay, this helps in writing the electronic configuration in easiest manner. Okay, so now already 2 electrons I will be filling in K because the maximum of electrons getting placed in first shell is 2. Now what I'll do, I'll just minus the other. Okay, the 12 minus 2 is how much? 10. But is there maximum, what is maximum electrons can be filled in L shell? It is 8. So I'll write here 8. Okay, now what is 10 minus 8? It is 2. Very easiest, right? So let me explain it once again. So how many electrons are present in magnesium? It is 12. Okay, now what? I have to start from K shell. Yes, means in K shell the 2 electrons can be filled, right? Then in L shell how many electrons can be present? It is 12 minus 2, that is 10. But limit is 8. Then limit is 8, right? In a L shell, the limit maximum electrons which can be filled is 8. Then in 8, the L shell, okay, and now how many? 10 was remaining, right? 10 minus 8 is how much? It is 2. Remaining 2 electrons are filled in M shell. So 2, comma 8, comma 2 is the electronic configuration of magnesium. 2, comma 8, comma 2. Now let us see for the other, okay, the fourth element, okay, electronic configuration, how do we can write? Let us take hydrogen. What is the atomic number of hydrogen? It is 1. Yeah, the electrons, most electrons can be present, okay, most electrons can be present in an hydrogen element, it is 1. So the electronic configuration is 1. Similarly for helium it is 2. The atomic number is 2, then the electronic configuration will be 2. Then for lithium it is the atomic number is 3. Okay, then 2 comma 1. Okay, for lithium it is 2 comma 1. How you will write the electronic configuration? In K shell, first I will write K, L, M, N, right? Then for electronic configuration for lithium, it is 2 comma 1. How? Now, atomic number is 3, right? Atomic number is 3. Now, 2 is filled here. Yeah? Then other one will be filled. Like 2, okay, 3 minus 2 is 1 then, right? So, lithium, okay, 2 comma 1. Similarly, we have this beryllium. Now, 4 atomic number. Now, 4, okay, we have this 4. Lithium has this 4. Now K can be filled with 2. Okay, 4 minus 2 is 2. 2 comma 2. Okay, 2 comma 2. Right? So other we have boron. Okay, let us look for the boron. Now what is atomic number? It is 5. Okay, it is 5. Then for boron it is 5. Then how you will do it? Okay, now 2. In K shell, how many maximum electrons can be filled? It is 2. Okay, now 5 minus 2 is how much? 3. Correct? Then 2 comma 3 is the electronic configuration of boron. The carbon we have looked. Nitrogen. Yes? What is atomic number? Atomic number of nitrogen is what? It is 7. Okay, 7. 2, maximum 2 electrons will be filled in K shell. That's for fixed. Then 7 minus 2 is how much? Yeah, it is 5. Now what is electronic configuration of nitrogen then? 2 comma 5. Right. Yes. Likewise we have oxygen. Oxygen total atomic number is 8. Okay. 8. Okay. Then one second. Yeah. I have oxygen atomic number 8. Then in K it can be filled 2. 8 minus 2 is how much? It is 6. Yes. 2 comma 6 is the electronic configuration of oxygen. Yeah. Now let us look into the, okay, neon. Similarly, what is the electronic like atomic number for neon? It is 10. Now 10, okay, 2 will be filled in K shell. Now 10 minus 2 is 8. Yeah, and in L maximum up to 8 electrons can be filled. Yeah, so 2 comma 8 is the electronic configuration for the neon. Now let us look for the sodium there. Yeah, let us look for the sodium. Sodium's atomic number is how much? It is 11. Sodium, okay, and A is the symbol, okay, and I have the atomic number called 11 there. So 2, okay, 11 minus 2 is how much? 11 minus 2 is how much? It is 9 then. But up to 8 only I can just do that. Okay, then 9 minus 8 is how much? It is 1. So 2 comma 8 comma 1 is the electronic configuration of sodium there. Yes. Then magnesium we have looked, right? So 2 comma 8 comma 2 is the electronic configuration of magnesium. Likewise, we have the aluminium. Okay, we look for the aluminium. Okay. Okay. What is the symbolic representation? It is Al, and the atomic number for the aluminium, it is 13. Okay. Now 13. Okay, 2 I will place here. Now how much will remain? It is 11. Then 8. 11. Okay. Yes. Then how much will like 11 minus 8 is how much? 3. 2 comma 8 comma 3 is aluminum's electronic configuration. Yeah, likewise we have the other electronic configuration. If you keep on practicing, it will be like really helpful for you to calculating the any electronic configuration of an atom there. Yes. Now looking into next topic, that is valency. Okay, but going before, okay, I want to talk about the noble gases. Before going to the valency, we have this noble gases. Now, what are these noble gases? Okay, there are some groups into the periodic table. Now, noble gas is one of them. Yeah, so noble gas is one of them. So, noble gas which comes under the group 18, or we call it as inner gases also, right? So, we call this as inner gases also. So, noble gases are also called the inner gases. They have valency 0 first of all. Now let me tell you the definition of valency. It is nothing but the combining capacity of an atom. We will be looking forward what is a valency. So like combining of capacity of an atom is valency. But we have to know like noble gases or the inner gases, these valencies are 0. Why? Okay, why? Because okay, most will react with other atoms. Okay, they won't react. Noble gases will not react with other atoms because outer shell is completely filled. Either they are duplet or octet structure, in octet structure. That means outer shell either they have only 2 electrons or they have 8 electrons in outermost shell. In this condition we see those are in doublet or the octet structure. This means neither they will gain, okay, neither they will gain or they will lose the electron, so they have the valency 0. Okay, so noble gases will contain the helium, neon, argon, krypton, xenon, radon or the oxygens. Okay, these are the noble gases, and we have to remember these noble gases will have the valency zeros because they have the duplet, okay, or the octet structure. That means the outer shell either they have the 2 electrons or they have 8 electrons. Now looking into the valency, as I said you, this is the combining capacity of an atom. Okay, now let us see that different atoms have the different types of valencies there. Now these are the elements. Okay, now we look into the previous chart, we had the atomic number for the these all 20 elements there. Okay, now hydrogen had the atomic of 1, helium at 2. Okay, now like this we have the, similarly we have the for the valency we have different atoms has a different valencies. For example, okay, for particular group has a fixed valency there. Now group number 1 has a different valency, group number 2 has different valency. As I discussed about the group number 18, which are the noble or the inert gases, those are nothing but the 18th group of the periodic table there. Yes. Now I gave the examples of the noble gases also, which was their helium, argon, krypton, xenon and all. Okay. Now let us look how to look into the valency or how to calculate the valency there. Okay. Okay. Let us take the example of nitrogen. Okay. Nitrogen has an atomic number of how much? It is 7. Yeah. Now, how you will write the electronic configuration? As I said you, it has the electronic configuration. Okay. Now 7 is the for nitrogen. Yes. Atomic number is 7. Then what do we write? How do we write the electronic configuration? We'll distribute this into shells K, L, M, N. Okay. Okay. 2 electrons are filled here. Then 7 minus 2 is how much? It is 5. Then 2 comma 5. Okay. 2 comma 5 is the electronic configuration for the nitrogen. Now see the outermost shell. Now this is the outermost shell, of course. Okay, 5 has how much electrons? It is 5. Okay, 5 it will not donate all these 5 electrons. Okay, now we are looking into this. Okay, we are looking to the nitrogen part. Okay, now it will not donate all the 5 electrons. No, because it needs a large amount of energy, so it will it will complete its octet, means it will fulfill its shell. Okay, it will fulfill its shell or it will become stable. Now what it will do, it will donate its 3 electrons from the somewhere for the other atom, or it if we take 3 electrons, then how many electron will have in the outermost shell? It is 5 plus 3. Okay, it is 5 plus 3, which is 8. Correct? So the nitrogen has valency of 3 there. 3. Now what we are adding, that is nothing but, okay, the electrons. Valency. Valency. Now, one more thing I want to tell about metals. Okay, now metals and non-metals are also the part of the periodic table. Okay, now let us take like metals. Okay, metals will always, okay, what they will do, donate the electrons. This you have to remember, this will donate the electrons, and non-metals will always accept the electrons. These will always accept the electrons. Now from this chart, okay, particularly, okay, we can see this potassium and the calcium, okay, now they can easily donate the electrons by the outermost shell electron to some any other element. So there are the metals, potassium, calcium, even the lithium, beryllium, for example. Okay, all this atomic number. Okay, now I'll take the example. Okay, let me erase this part. Okay, let us take, for better understanding, let us take aluminium element. Okay, aluminium element. Now, how much, what is the atomic number of aluminium? It is 30. Okay, now outermost shell will consist 3 electrons. So it can easily donate the 3 electrons to the outermost shell. Now, if you see the electronic configuration, okay, and the aluminium, the valence is 3 here. Okay, now it can easily donate the electron. Okay, it can easily donate, right? So this 3 is the electronic electron. Okay, now the valency which it is donating. Similarly, okay, similarly, we can take the example of chlorine there. Okay, now what is chlorine's atomic number? It is 17. Okay, it is 17. And what is electronic configuration of it? It is 2, 8, 7. I'll explain you how it came. So now 17. Okay, 2 electrons are already. Now 17 minus 2 is how much? It is 50. Yeah, for next it is not possible. Then 15 minus 8, for the 7. So 8, 7 is an electronic configuration of chlorine there. Then valency, it is expecting, right? It is accepting the outermost shell. Okay. Now, as you can see, the chlorine, okay, it is accepting the one electron. Okay, so that is non-metal. So non-metal, these are always accepting, and the metals which donate the electrons. Now this was the part of valency. Now similarly we have this chart, okay, which I have presented here. So respective elements have the respective valencies, okay, with symbol I have mentioned. Next part we have the list of formulas of some important compounds here. So let us look what are these formulas now, which are really very important, because without this knowing, okay, you cannot write the reactions of compounds, please. Suppose you get the question, write the reaction between the zinc and the hydrochloric. Okay, for writing reaction, you should know the symbol of zinc. Okay, so I have listed, sorry, I have listed some of the chemical compounds and their common names with their chemical formulas. Here are only few, okay? These are the few very important, okay? But other are also like mentioned. So I am taking your example of zinc hydrochloric. Okay, now let us say first you should know the symbol of zinc there. Okay, now what is symbol of zinc? It is Zn. Okay, and what is formula for the hydrochloric acid? It is HCl. Okay, now if you know the symbol, you can easily write the reaction for this. Now zinc plus hydrochloric acid, this will gives you zinc chloride plus H2. Okay, H2. Now this H2, when the zinc will react with hydrochloric acid, it will get zinc chloride and the H2 gas will evolve in this reaction. Now this is the reaction. Okay, for this we need, okay, to remember the formulas of some important compound. For the acetic acid, we have now the common name for this acetic acid is aspirin. Okay, and the chemical formula is C9H8O4. Similarly, we have sodium bicarbonate, and this the common name is baking soda, and the chemical formula is NaHCO3. Sodium, okay, bicarbonate. Then we have the sodium hydroxide also. Sodium hydroxide. Now caustic soda, okay, that is known as the sodium hydroxide. That is written in the term of chemical formula as NaOH. Yes. Then we have this washing soda. Okay, the dry ice, which is okay, that is known as the carbon dioxide. Now this is very famous, okay, always taken by name in the syllabus. And also dry ice, that is written by CO2, common name is dry ice, and the chemical compound name is carbon dioxide. Yeah. Similarly, we have the sodium tetraborate also. Yes. Thank you. These were the basic concepts which I have discussed, which are really very important.